Okay, ladies and gentlemen, so we're looking at solving right triangles and word problems. So what does it mean to solve a right triangle? To solve a right triangle means that you're going to know all of the side lengths for that triangle and all of the interior angle measurements. So to solve a triangle means that you know all three side lengths and you know all three interior angles. When we do questions like this, we have three main tools that we use. The first one is Pythagorean Theorem. Now, let's remind ourselves about Pythagorean Theorem. That is when we have a right triangle. Let's be very, very clear here. Pythagorean Theorem does not have anything to do with triangles that don't have a 90-degree angle. If they don't have a 90-degree angle, then we have no business talking about Pythagorean Theorem. If it does have a 90-degree angle, then there's always a side that we call the hypotenuse. It's opposite the 90 degree. The other two sides are called the legs of the triangle, and I've just randomly called them A and B. And Pythagoras' theorem says that if I take A and square it, and if I add that to B and square it, I'll get the answer equal to the hypotenuse squared. And remember, it's always the hypotenuse that's by itself. We got to keep that straight. ASTT stands for angle, sum of a triangle, theorem. And what that means is that when I have any triangle at all, any triangle, could be a right triangle, could be any type of triangle, that the angles, if I call them A, B, and C, that angle A plus angle B plus angle C must add up to 180 degrees. Always. And remember, we're talking about the interior angles there. ASTT. And, of course, the three trig ratios that we've learned. So the three trig ratios are sine, theta. Notice it's not sin. That happens in religion class. This is sine, is opposite over hypotenuse. And then there's cosine, which is adjacent over hypotenuse. And finally, there's tangent, which is opposite over hypotenuse. And, oh, no, opposite over adjacent. Ooh. And so, let's see if I can spell that properly, or at least have it so you can read it. Opposite over adjacent. Now, and the way to remember this is they have a short form for remembering it. You use sine is opposite over hypotenuse. We call that so. Then you take cosine, which is cosine is adjacent over hypotenuse. And finally, you take tan, which is, when you put it all together, you get that famous word SOHCAHTOA. All right, so let's take a look at example number 1. We're going to round to 1 decimal place if necessary. Now, there's all sorts of different orders I could do this in. Okay, and it's completely fine to use a different order, in which case if I do it in a different order, I'm going to use different tools from above. I choose at this point to go after, I think I want to go after this side over here. But I'm going to start off this way. That's going to be my 90, so this is going to be my hypotenuse. This is an angle that they're giving me, so for this angle, this is going to be opposite. And for this angle, this will be adjacent. I'd like to call this side something. We could call it CA or AC, and that would be fine. I could call this side AT or TA, and that would be fine. And there's another way of naming this. I could also call it little t. So what you do is you take the vertex that's opposite the side, and we're going to call it little t. You take the vertex that's opposite the side, that could be A, but I'm always going to call it hypotenuse. And the vertex that's opposite this side is C, so I could call this little c. And those are just different ways of naming this triangle. And this triangle is in triangle CAT. Oh, look at that. It spells something. So in triangle cat. All right, so again, looking at this, I need to go after something first. I'm going to choose to go after this side over here, this side T. So I'm going to use this angle. This angle using opposite and hypotenuse is going to be sine. So sine of 23.6 equals little t over top of 25. We remember this work from earlier in our post yesterday. So this is over top of 1. We'll cross multiply. We'll get 25. Sine of 23.6 equals t. And we're going to get a final answer using a calculator, making sure you're in degrees. And I get 10.0. So t is approximately equal to 10.0. And that was my first step. Second step. You know what I didn't go after right at the beginning, and probably I should have? That looks a little bit simpler. What about angle C? Angle C is sitting up here all by itself, and angle C is going to be found by 180 minus 90 minus 23.6. And that's going to be 90 minus 23.6, 66.4 degrees. That's angle C. So it doesn't matter when I go after what. What matters is I eventually get everything I need. So this has been worked out to be 66.4 degrees. This has been worked out to be 10.0. And I guess the thing that's missing now is this side here. I could use Pythagorean Theorem if I wanted to. I'm not going to. I think what I'll do instead is I'm going to, well, let's organize my work. Let's make this step 1. Let's make this step 2. And let's do step 3 over here. Step 3, I'm going to go after C. I could use Pythagorean Theorem, or I can use the trig ratios again. And which one I use depends on which I'm working with. So I'm going to work with the 23.6 again because I want to. This is the adjacent, and that's the hypotenuse. I could have worked with the 10, but again, I want to work with the 25. So adjacent and hypotenuse is going to be cosine. So cosine of 23.6 will be C over top of 25. We're going to cross multiply. Remember, the cos of 23.6 is just a decimal. So I'm going to work with that as a decimal, 23.6 cosine times 25, and I'm going to get an answer of C equals 22.9. Okay, so keep your work neat. Keep it so I can find it, and that way I can give you answers for it very nicely. This would be a really nice touch. In triangle CAT, you could say angles, and you could list all your angles, angle C, angle A, angle T. So angle C is going to be given by 66.4. Angle A is 90. And angle T was given by 23.6. And then you could put sides over here, and we can say that we have little c, little a, and little t. Notice that my little letters always have the little tails on them. So little c is opposite the vertex c. So here's the vertex c, so that'll be little c. And we work that out to be 22.9. And little a was given as 25. And little t was given as 10. Well, it wasn't given. We had to find it. And if we put all of that in a nice little box, you're going to make me very happy marking. So when I come along to a question like this, what I'm going to see is I'm going to see the work that you've done. I'm going to see the separated work, and I'm going to start here. I'm going to go, yep, they got it right. Yep, they got it right. Yep, they got it right. I'm going to check quickly here, make sure you haven't lied to me about anything, and I'm going to give you full marks. If I have to go wading through it, then there's more chance of me finding something that you've done wrong, less chance of me being a happy marker. Happy markers can find what they need to mark, and check marks come easier that way. Let's look at the next example. So I've got a triangle here. I'm going to start off by finding D, little d. Hey, it sounds like a rapper, little d. So I'm going to work with Pythagorean Theorem, I think. So little d squared plus 7 squared equals the hypotenuse squared. And if you're still having problems with this, there's no problems with starting off saying, you know what, there's my hypotenuse, and just label it and be done with it. So working with this, little d is now going to equal 18 squared minus 7 squared. So that's going to be 18 squared minus 7 squared is 275. So I'm going to square root that, and so d is going to be plus or minus 16.6. And because it's a triangle, we're going to omit the negative. So I had my big argument with both cohorts now about why we need to do this, that there are in fact two answers when we square root, and you're in grade 11 and you have to show it now. And I think I was very good at explaining why it needs to be there and why we're omitting it. Now it's up to you to do it. And if you don't do it, you're going to lose some marks. So that's up to you at this point. But yes, it's something that we need to do to show that we know that there are two mathematical answers, but only one of them makes sense to this problem. So that was step one. Step two. So step one, that was 16.6. I have all three sides. So now I want to go after an angle. So let's say I go after angle D, because it's just sort of sitting there and it's looking so nice. I could have gone after angle G, but you know, I didn't. So looking at this, I could use opposite, I could use adjacent, and I can use hypotenuse. I'm going to use adjacent and hypotenuse because those were values that I was given. If I've made a mistake with the 16.6, I'd rather not include it in something else that I'm doing. So I'm going to go after adjacent and hypotenuse, I know, so that's cosine. Cosine of big D, oh, there's another wrapper, big D and little d. So it's going to be, big D is going to be adjacent over hypotenuse, 7 over 18. And at this point, you should know, you should know that you're going after an angle. So angle D, you have to use the inverse of cosine. Now that's all one symbol. Cosine of 7 divided by 18. 7 divided by 18 is a decimal. There it is there. I would have to write out as much of it as I have to be as accurate as I could be. Instead, what I'm going to do is I'm going to let the calculator do the work and leave it as 7 divided by 18 on my page. So shift, cosine, and I get angle D is equal to 67.1 degrees, approximately. Last thing, number 3. I guess I know what D is. It's 67.1. So if I know that this is 67.1, I know that this is 90. Getting G shouldn't be that hard. Angle G, ooh, different color. Angle G is going to equal 180 minus the 90 degree angle minus the 67.1 degree angle. So now notice that 180 minus 90 is 90, so I always start with 90 minus 67.1, and it's going to give us 22.9 degrees is angle G. So you want a happy marker. Your job from now until October the 14th is to keep Mr. White happy. So you're going to put things around that. Very, very happy, happy Mr. White. You're going to say in triangle, D-O-G, dog. Get it? We had triangle cat, we had triangle dog. Okay, so we're going to go with angles here. Angle D, D, is 67.1 degrees. Angle O is 90. Angle G is 22.9. Sides. Little d is 16.6. Little o is the hypotenuse. It's going to be 18. And little g is going to be 7. And you put a little box around it, and I'm a happy camper. And happy campers give check marks. Yay! We're going to stop the video there, and then we'll come back with word problems.